So like the binomial distribution or the multinomial distribution, the Poisson is a widely used distribution for discrete random variables, so probability mass functions. And it's the final standalone distribution that we'll cover. It's named after the French mathematician Siméon Denis Poisson and is used for count data. For example, the number of cars that drive by in a minute, the number of guests at a restaurant in an evening, or the number of new hires in a month. The first argument to the NumPy-Poisson method is lambda, which must be greater than 0 and guides the peak of the Poisson probability distribution. For example, sampling from a Poisson with a lambda equal to 5 will tend to draw samples near 5. So let's set this lam, short for lambda, variable equal to 5. It's just a scalar value. And our second argument is the number of samples to draw. So we can pass both of these variables as arguments into the NumPy random module Poisson method. And that gives us our samples, so we can look at the first 20. So we're going to tend to draw samples near 5. And what this is saying is that if this was the number of cars that are driving by in a minute, in this sample, 2 cars drove by. In this sample, 2 cars drove by. And in this minute, 4 cars drove by, and this one 6, and so on. So we have that for each of our 1,000 samples. So we can use this line of code here to give us the number of instances from our 1,000 instances that had a certain count. So, we're tending to get them around 5, as we'd expect. So in the 0, 1, 2, 3, 4, 5th, the 0, 1, 2, 3, 4, 5th position, that's one of the most popular buckets. And yeah, so that corresponds to this lambda being equal to 5. So if you don't quite see what's going on here, where we have this unique method is telling us out of the 1,000 samples, 4 of them have a count of 0, 44 of them have a count of 1, 82 of them have a count of 2, and so on, up until 3 of them have a count of 13. Theoretically, the top is unbounded, but practically it's limited by whatever lambda is set to. Okay, so we can plot this out nicely. Let's convert these counts into probabilities by dividing by n, which is equal to 1,000, and plot everything out. And so we can see our probability mass function of a Poisson distribution with lambda equal to 5. It looks like that. Nice, so that's our final standalone distribution. Up next, we're going to talk about mixture distributions, which combine them together.